So Nick McKay is an associate professor at Northern Arizona University in the States. He researches climate dynamics on a range of spatial and temporal scales, and he uses a host of different approaches to achieve this. So he uses field and lab work to develop new records of past climate, and then informatics and machine learning techniques to develop infrastructure. I think the one we are familiar with is probably lipid. It's definitely the one I'm most familiar with. And then different approaches to integrate observations and numerical models. Today, Nick will also discuss how the Pages 2K network and other projects have been curating data. He will introduce some emerging tools built around the lipid framework and how these approaches are contributing to scientific discovery. And he'll talk a little bit about the 2K network data stewardship plans in the future moving forward. Right, Nick, I think it's off to you.
Okay, great. Thank you. Thank you for the introduction and for the invitation to present here today. Data stewardship is something that has consumed a lot of my time and thoughts over the past decade, but it's not the kind of thing that I get asked to talk about that much because, well, there's a sort of a limited audience for it. But you are it. You are the audience for this. So I'm really happy to present on this. There's a lot that I could say. And so I think, again, feel free, there's things that were left out for sure. And I'm happy to go into more depth or detail or cover things that I omitted entirely in the questions. So please do ask questions if they come up, probably best at the end. Again, talking about data stewardship, and I know a few of you already had some comments, are capturing this, recognizing this photo on the bottom of the title slide here. I don't know that I would have before I was looking it up, but we're talking about data stewardship or stewardship in general. My first exposure to the concept of a steward actually came from the Lord of the Rings series, from The Return of the King, and with this guy, Denethor II, I guess, who was the 26th steward of Gondor in the books and in the films, and the concept there being that he was not the king, and the stewards were taking care of the kingdom while the king was away. And this connects really, this is what, and the idea here with data stewardship being that data stewardship is there's this quote from the Data Governance Institute. It's concerned with taking care of data assets that do not belong to the stewards themselves. And in practice, a lot of the goals and efforts associated with data stewardship is really closely related to this concept of making data fair, which is, I'm guessing, something that many of you have heard of, but if not, I'm happy to review that. These are the key, it's an acronym that stands for findable, accessible, interoperable, and reusable. And with all of our, with the data in these Pages projects and things that we're working on, if we're achieving these goals, we're doing most of what we're trying to accomplish, pretty much everything we're trying to accomplish with data stewardship. We want people and users and scientists to be able to find the data, have access to them internationally or wherever they need to get it, to have it work within their systems, and then for it to be reusable, and for our science to be sort of clearly reusable, but also repeatable, such that our results and our findings are really clear, and that somebody could go on, find the data, reproduce the results that we produced, and convince themselves that what we're doing is legitimate. I think that along that last lines of sort of transparency, transparent science, and reproducibility, data stewardship is really important in the study of the climate of the Common Era. I think a lot of what we've done in the 2K network and other projects over the past decade was motivated by the controversy of early reconstructions of the climate of the Common Era of the past millennium, and the hockey stick curve, which as I'm sure you all know, were very controversial in some realms. In part because the data were just accessible enough that people could start to play with them, but not enough that it was clearly reproducible, or all the assumptions and choices were made were clear and transparent. Right. So I think a lot of the effort that we've put into data stewardship was really motivated by these controversies and by claims that the science that was being done by paleoclimatologists working on the climate of the Common Era was sort of, bad science or a hoax or not reproducible. And to that end, we've put forth a lot of effort because, as we've shown, and as everyone who's worked on it knows, everything we do sort of reinforces the key finding that the warming of the 20th and 21st century is very different than the climate of the millennium before that. And what we want to do, or what many of us, we want to make that as clear to anyone who wants to get into it as possible. And so again, having data stewardship, having data well curated, available, and our science reproducible is really important for the community and for discourse and policy. And because of that, I think that data stewardship in this realm, in the 2K network, really has pushed the rest of the community forward. And we're now, I think, at a much higher sort of level of accountability, and achieved sort of much more fair data, so to speak, than we would have otherwise. And then I think other aspects of our field have got to so far. So in a lot of ways, this controversy has motivated a big improvement in our field. Okay, so I think I'm going to spend a few minutes going over what this has looked like, just as a bit of background, because it's been both a pretty slow process, but then also looking back over most of a decade now, it's sort of remarkable to see how far things have come along over that time. So going back to the first, the compilation of the regional networks back in 2013. This is when I first got involved with the Pages and Pages 2K network. And this is, again, that project was, I think, largely motivated to have regional groups pull data together in a comprehensive way, in a clear way, and make that available. And so it really motivated, again, a lot of this of trying to figure out what we should be doing with our data was the best case. It was a different world back then, and at that time we were pulling data together primarily in Excel. But one thing that came out of that was the 2K network groups that spent a lot of time working with the World Data Service for Paleoclimatology at NOAA to develop sort of it had a big input on what their updated standards were, and we worked together through that. So those of you who were involved in that project will recognize some of these Excel fields that were used to pull things together. That was great, and it led to this paper and some really important results. But we weren't where we wanted to be yet in terms of especially interoperability and reusability. And so we started going closer towards that. So falling off of that, we had sort of an updated version, or a slightly extended version of the Arctic region that I was involved with, that again was using this updated World Data Service for Paleoclimatology format, and then storing chronology ensembles as netcdf files. And this is how we published the data for this paper back in 2014. And I think at this point we realized that this is machine readable, and it was a big improvement, but it was still not quite what we wanted. We wanted to be able to encode a lot more metadata, have this all sort of stuck together in a really robust way that would be flexible enough to accommodate a very, very diverse set of data. And so going from this is when we started pulling together LIPID, or the Linked Paleodata Framework, with myself and Julian Emile Shea. So we published this as a sort of concept paper before we had really implemented on a large scale. And again, the idea being that this is a data model that's really flexible. It can be represented as files, as in sort of lipid files, or as serializations in different and sort of any sort of programming interface, and we started implementing this moving forward. I'm not actually going to go into the details of lipid today, so the structure of how it's structured or how it works or any of that. If you're interested in that, there's actually, I gave a webinar for Pages a few years ago that goes into this, and there's a few other places, so you can check this out. The link's at the bottom. I will note that this YouTube video has been sort of universally praised, so 100% positive reviews. So if you're interested in learning more about lipid, feel free. I'm sure that you'll add to those 6 people who really liked it. Okay. And so at that point, and then moving forward, we've really been focusing on using lipid to, in these large compilations, starting with the Pages 2K temperature compilation in phase 2. So Pages 2K phase 2. And so this is the first compilation that really focused on using, that used lipid explicitly. And this is and so this came out in 2017, and having all those data organized in that framework, and then being able to develop code bases around those to do temperature reconstructions and other things led to some really, these key publications that came out over the past few years, looking at time series reconstructions with different methods, climate field reconstructions with different methods, and a lot more science. We've seen these data really be really broadly used. And since then, this has expanded to many more compilations. These are sort of 4 more compilations that have used lipid in a similar framework to what we did in 2017, just over the past couple of years. Some of them are some are 2K, some are much longer, going back for PalMod, goes back 130,000 years. ISO2K is in here. And in addition to these ones, which are now published, there's sort of 4 or 5 more sort of comparable type projects that are in the works using this framework. So it's exciting to see all this coming together, and the pool of data that's available for different questions and projects really growing. And I think at this point, it'd be good to, especially for this audience, to talk about what this looks like in practice. Because yeah, it's not, it can, there's a lot to it. And so getting data into these compilations, it's a very iterative process. And so there's multiple steps, and it goes in circles, but there's some, so first you have to get a bunch of data into a lipid framework format. There's different ways of doing that. This video here is showing using this online tool, the Lipid Playground, which is the easiest way if you're looking to create a file from scratch, editing a bunch of data. You'll see here later, you can sort of copy and paste data in and describe it here in a lot of detail. This video is actually a few years old, so there's been some innovations on this webpage since then, but the basic idea is the same. For the large compilations too, often there's a lot of data that are already formatted in either in some sort of standard format, whether that's Excel spreadsheets or a sort of in-house serialization and like say MATLAB or something, that we're able to develop sort of custom converters for, and do sort of bulk imports to get a lot of the data in. That's the way that a lot of the data have come in for a lot of the projects. But again, getting a bunch of data into Lipid first is often a key first step for what this looks like in practice. Once the data we have some subset of the data in Lipid, we will create one of these. And so this is what we call a QC sheet. And what it is it's just a giant Google spreadsheet. This is the example from ISO2K. That has, especially in the case of ISO2K, a very large amount of metadata. And then also lots of columns there being metadata, and then lots of rows corresponding to each of the time series. So this is really nice if you're trying to standardize metadata or sort of add new metadata fields consistently across lots and lots of records. It's much more, it greatly simplifies the process as opposed to editing individual files, Lipid files. What's also great about this is it's Google Sheets, and so you can share this really broadly, and we can have dozens of different contributors and collaborators on the project all working together to standardize this. And so those are sort of the two sources of information. Once those are done, we and then we use this Lipidverse website, which has some simple just diagnostics and visualizations of the data, so that you can take a look at what the data look like, where they are in space, and then go back and edit the files if you need to edit the data, or edit the QC sheets if you're looking to edit the metadata. So again, this is a really iterative process, and this is sort of what that process looks like. You can imagine starting over here on the bottom right, you're adding new data sets that comes in, you update the compilation, you push that compilation up to Lipidverse, and then it gets reviewed and edited, and more data and metadata come in either directly through the files, if it's looking through like lipid.net, if you're editing the file, the data themselves, or the metadata, if it's the QC sheet, and then we run another update. It's typical in the large compilation projects for there to be dozens, if not hundreds, of iterations of these cycles. Sometimes they're really small, just a few changes that are updating to a few files. Sometimes they're really big. But because of this, this iterative process, because again, it's impossible. If there's one thing we've learned, it's impossible to have everything that you want in a compilation to be right the first time. And so we just plan on it being iterative. And because of this, we have to, so when we're making we have to make new versions, and we keep track of, there's some version control. When we do the versioning, we integrate the updates both on the files from the data and on the QC sheets into a single new version. Because of that, it's really important to keep track of the versions. And so we have this versioning scheme, and we keep every version of the database, at least. Sometimes some of the very early ones we get rid of if they're no longer helpful, but it has this 3-character, it's really 3-number system that for describing, keeping track of where you are in the versions. So A, the first one, it's a number that all these numbers would start with 0, and then they would increase by 1 every time it ticks. And so A ticks every time there is a publication that describes the database. This is why the database for pages 2K phase 2 was 2.0.0, because it was the second publication describing the pages 2K temperature compilation. When one of the numbers further to the left increases, it resets the other ones further to the right to 0. B, the middle one, increases every time the set of records changes. So if you add a new data set or remove one, or replace one, then that would tick. And then the last one changes only if the set of records stays the same, but the metadata change, then you would tick the third one. So we keep track of these while developing a compilation before publication. I know, I can't remember where we got with IC2K. I think with the temperature 12K recent compilation, we got, I think that B one was around like 46 or something by the time we submitted that for publication. So it happens, so this is and that's not counting metadata changes. So the idea is that this continues to tick after publication as we fix metadata, as new data sets come in, and that users of the database can reference which version they use to help make sure that their data are reproducible, and then those versions would be available, especially post-publication, so that even if there's been improvements or extensions to the compilations later, the results from any are always reproducible. As you can imagine, just keeping track of what versions are is really important, but also keeping track of what changes between versions is also really helpful. So this is actually one of the newer things that we've implemented, is we've added change logging that describes what changes both within a file and then between compilations. And then this goes on to the Lipidverse website as well. So this is an example from temperature 12K. So this is a summary of all the different things that change between version 1.0.1 and 1.0.2 across the whole compilation. But then all of the detailed changes for each file are also on there too. And so again, this was a pretty large change where we were standardizing some of the terminology and fixing a couple of mistakes. But all of this information is stored within each of the files, and then just represented here on the web, so that if somebody's interested in what changed or why it changed, that information's available and moves with the data. Because so in addition to versioning compilations, we're also versioning data sets with a really similar scheme. So that is essentially, it's virtually identical, with the difference of, instead of the middle one being, instead of the set of data in the compilation, it's the actual data in the data set itself. And so if there was a mistake or an addition, so if you're adding chronology data or something into a file, that you would tick that middle one. Otherwise, it's a similar concept. And so we can keep track of both how individual data sets are evolving, in addition to how compilations are evolving, which is really important too, because especially some of our data sets are shared between different compilations. Okay, I want to change gears a little bit and talk about data standards. Many of you are probably co-authors on this manuscript, which came out a couple of years ago, led by Deborah Kiter, and about this a controlled vocabulary, sorry, not controlled vocabulary, that's where I'm going next, a reporting standard for paleoclimate data. And really the focus of this is, and the focus of this manuscript, for those of you who are unfamiliar with it, is to ask the paleoclimate community what should be included in a paleoclimate data set. And ideally, what fields should be there, not necessarily what we're going to call those fields or how they're going to be structured, but just what should be reported, whether the fields should be sort of mandatory, desired, required, optional. Interestingly, or maybe not surprisingly, when we went around and asked people what should be in there, the standard was pretty high. When reusing data, people have very ambitious goals about what they'd like to see included in the data sets. But when sharing and providing data, people tend to be much less ambitious. And so in lots of ways, this is a very ambitious goal, and we haven't implemented PACS in any Pages projects yet. It's again, you'll note that this is called PACS 1.0. The idea is that this is going to evolve, and it's probably going to evolve towards a more pragmatic solution, but we were happy to have this out here as at least a sort of aspirational goal. And another aspect of data standards is work that's been done by our colleagues at the World Data Service for Paleoclimatology, and they've developed this PAST thesaurus, and this is a different aspect of data standards focused on what we should call the terminology to use for the field that we're storing. So again, different than PACS, in that it's not saying what should be there, but it's saying what we should call, and can we all use a standardized vocabulary, standardized terminology for the terms that are there. Because there's some interesting, so we have Lipid, which is a sort of a data framework. It's also a type of standard. So there's 3 different types of data standards that we're using here. And so I wanted to sort of go over that briefly with an analogy. So, and I spent most of the first half of this year overseas, and so trying to find appropriate power adapters was a large part of my life for many of those months. And so this came to mind as an apt analogy. So again, if I was in New Zealand, and so having just an adapter which would allow me to plug my US appliances into a New Zealand outlet required an adapter that was just matched the shape of the outlet. And that's effectively what Lipid is. It's a structure that's going to control the shape, the structure of the data. But just because I could plug something in to the outlet didn't mean it was not going to make my appliance start smoking. And that's where the analogy with PACS and PAST would come in. And so again, it's not a perfect analogy, but you can imagine that for a standard to work well for electrical outlets, you need to have both the shape, the current, and the voltage all be prescribed and working, interoperably through them. We've really focused, and bringing this sort of back to the 2K network, we focused almost all of our efforts so far on lipid, on getting the shape right, making things so that you can read them and write them across platforms. But what that means is that you can't rely on consistent expectations for what you're going to find once you plug it in. So so that means you have to do some of the conversions potentially for current and voltage after you've plugged it in, which again works fine for some appliances and not for others. Again, ideally, you'd have all three of these things working together nicely, and that's certainly where we like to go. But it's non-trivial, and so that's sort of a future direction. And uniting these different aspects of data standards is a goal for coming years. Okay, I sort of want to talk briefly about the state of the Lipiverse and what's available on there. So there's currently more than 3,000 datasets on Lipiverse. The overwhelming majority are associated with these major compilations. There's these published compilations, which I mentioned earlier, which again, we're keeping track of version control. And there's several more that are sort of coming online currently. So the way that we've handled this is that as compilations are coming online, they're on Lipiverse, but not sort of publicly available until they get published, and just so that during the interim, while it's being used in a more of a quality control manner, it's not immediately accessible to sort of everybody on the internet, but then it can become so once it's ready to become for that to happen. In addition to more and more data, we're working to expand this a bit. So part of this is a website redesign mostly just for the front end that would just better describe sort of what Lipiverse is, its goals, and how to use it. And a major aspect of this would be some tutorials highlighting how people can use Lipiverse and lipid data to do some sort of a wide range of different things. So so keep an eye out for that as it comes. And something else that we're working on as part of another project, which I'll mention here a bit later, is improved programmatic access to the data, where you could query the Lipiverse and ask it, okay, across all of the data that's available, give me the data sets which fit these criteria programmatically, so that you can design workflows around that, which can be automatically updated as new data comes in. So along those lines, I wanted to sort of spend most of the rest of the time here talking about other stuff that's coming up that works natively with all of these data that have been developed as part of the 2K network and other pages projects and other non-pages compilation efforts, which are all using this sort of lipid framework. And this is a good point to take a step back and talk about a linked earth. I know that this can be very confusing distinction for the difference between lipid and linked earth and what those are. So I thought this is a good spot to review that. So Linked Earth is a project. It started out back in 2016 as a EarthCube funded project that was focused on doing a lot of the stuff that I just described, along with some community development with the wiki. But it's really grown since then, and there's sort of four main things that are sort of under this Linked Earth umbrella. So I think it's appropriate to think of it as sort of a large umbrella that is trying to coordinate and advance a lot of different efforts in this space across the paleogeosciences. So you see on this nicely colored circle, this figure, which is produced by my colleague Deborah. There's these four different aspects, which are data stewardship, which is the bottom left, what we've been talking about so far today, and these data products, which is sort of closely aligned with that. And then there's these analysis quadrant there, which again, all these things would play nicely with each other. So have data products, which would then play nicely with analysis tools. And then there's this community aspect. So standards, products, analysis tools, and discussions and workshops and trainings are all sort of part of what we're trying to do. And then lipid is one piece of this amongst many. And just to, so the leadership here is myself and my colleagues, Deborah Keider and Julian Emilje, and who have been sort of my main co-conspirators on most of this work. Okay. So just to review some of these things, some of these tools and other things that are happening in this space, which is relevant to this. So geoChronR is an R package, which interfaces with other sort of existing age modeling tools in R primarily you can run them, extract age model ensembles, and then propagate those age uncertainties through through subsequent analyses. The ones that are built into geoChronR and sort of work out of the box are these 4: correlation, regression, principal components analysis, and spectral analysis. But then it also has sort of the low level tools to, if you want to build custom analyses, it's certainly easier than starting from scratch. Here's sort of here's an example of what one of these sort of outputs looks like in a way that would be sort of network focused. Here is doing an age uncertain principal component analysis here for the North Atlantic region. So again, like tutorials highlighting how to do this are available both in the manuscript that just came out describing this, but also online. So some of so ISO2K is part of the ISO2K group is now trying to use this, or is successfully using geoChronR to extend some of the ISO2K work into age uncertain space. There's a lot of work that has to be done on the chronology space, because a lot of times even after a data compilation comes out, the chronological data are in poorer shape than the in that case, the sort of the isotope data, or what we call the paleo data. But again, these tools are scalable up to sort of compilation and project level, and so we're excited to see more and more people use, or more and more groups potentially using this. Sort of in a similar space on the Python side, there's this package called Paleoclimate, again, that Julian and Deborah are leading. This is it focuses more on time series analysis, and we've had a big focus recently on training people to use this. We had our first paleo hack workshop earlier this year, and then we're gonna have our second one virtually in the end of October. And so if you're interested in learning how to use these tools in Python, we'd love to have you enroll for that hackathon. Other things which are a bit earlier in their development, but that are coming down the line, and again play nice with Lipid and these data compilations, is this abrupt change toolkit in R, Actor, which we're developing as part of the Belmont Forum funded project. That it's similar ideas, but it's being able to take age uncertain data and then propagate them through with age uncertainties through various types of abrupt change detection algorithms, and then apply robust null hypothesis testing to get what are hopefully very, very reasonable and robust results across sort of large networks. This package is being very intentionally designed to make it easy to plug in new methodologies, and so hopefully we're really hoping to be able to collaborate broadly in this, and so I'd love to collaborate with people who are interested in this on this project. And then sort of even newer is a project that we're calling PReSto, which stands for the Paleoclimate Reconstruction Storehouse, which really is very it fits really nicely, I think, into a lot of Page's goals, and I'm really excited about this. I think that some of the goals of this project are really what we had in mind when we started thinking about data stewardship and on sort of Page's project scale 10 years ago, where we have standardized data and then standardized pipelines for analysis, where as new data come in, we could have climate field reconstructions or index reconstructions that can get updated automatically, or that users could tinker with options, parametric choices or methodological choices, and then have easy access to updated reconstructions or alternate reconstructions. So this is, again, coming online. We just finished the first year of this project, so stay tuned for this. It's really trying to streamline a lot of the steps, and then increase the reproducibility of a lot of the steps of what often happens in these large compilation projects. And so we're really excited to collaborate with people on this project as well. Change slides. There we go. As part of that project, and this is again another sort of advance, which is currently online and available, and a manuscript is going to be submitted soon. That's, I think, going to be helpful for some of the these compilations. Is this recommender system that so Deborah led the development on, and what this does is much the way that like Netflix or Amazon will recommend you to watch or buy something. This uses the pool of data available and some internal logic to recommend metadata fields as you go through. So here's sort of a quick example of how this works, just really quick. And so you can see this. So as you start to make choices, as you're describing a data set, this will make hopefully reasonable suggestions based on the other data, and so this is again still in development, and I think there's a lot of room to potentially customize this and to work closely with network groups as they're trying to develop as they're working through their data sets, and the goal here being, well, two goals: one, making it easier on users, but then also resulting in more and better standardized terminology on the final files that come out of it. And then lastly, we just learned this month that we have this PaleoCube project being led by Deborah Kiter. Is going to be funded by EarthCube, and some of the key things we haven't. So this is launching in September, and the sort of major goal is some cloud-based Paleoclimate and climate model integration tools that let you take lipid data and more effectively and efficiently compare them and integrate them with model output. But as part of this, we're also going to be redesigning and expanding the sort of lipid tools in Python. So again, this is something that's coming out on the horizon. So there's really a lot of stuff that's sort of emerging, and some of it's works pretty smoothly and operational now, and some of it's in early stages. But it's continuing to sort of build up capacity around the compilations that are coming out, and so we're really starting to get some of the benefits that we were dreaming of 10 years ago when we started down this path of improving how we did data stewardship. So again, I'll just sort of summarize and leave a lot of this here. So the 2K network, I think, motivated and has driven a lot of the advances. And I think at times, I know for myself, I'm sure for others, it feels like the progress on this has been slow, and it has required a lot of effort. But I think as you look back and now we're starting to see some of these, the capacity, the expansion of capacity and the sort of the scale of some of the science that we can do really grow because of the effort that we're putting into this. And so there's still a lot more to do. Yeah, anyway, I'm excited about the direction this is going. Again, I'm really happy to take any questions, and especially if there's aspects of data stewardship that I didn't cover, I'm happy to comment or address those because it's a big topic.
Thanks a lot, Nick. That was great. It was really nice to see where it all started and how it's moved and how it's being used. And thanks for straightening up the linked earth, past lipid, all of those things. And it's really nice to see what's coming in the future. We saw some of the geoChronR bit. I think Georgie brought it up last time. And then PReSto looks really cool for when it comes up. That was amazing. I can see a lot of clap icons. I'm not sure you can hear it, but that was a really nice presentation. If anybody has questions, you can put them in the chat, or if you want to raise your hand and just ask the question, that would be good as well. We have about 10 minutes. Sorry, I'm trying to keep track of raised hands, but in case I miss you, feel free to start your mic and just ask a question.
I see Martin has a question.
Go ahead, Martin.
Hi, very interesting talk. I have a question about the standardization and people whose first language is not English, I could imagine could there be tools to say produce some translation tools for say Spanish-speaking users. Would that be possible to do some sort of to assist with users with
Yeah, that's a really good question. That's something I haven't done. I haven't done a lot of research for I mean, certainly one of the things we commonly run into, which is really frustrating, is that different platforms and computers, we have trouble with sort of non-basic Roman characters that show up in metadata fields. So that's a different question, but a sort of a related frustration. And in terms of expanding sort of software, both documentation and terminology to non-English speakers, or especially where it's not first language. I think that'd be great. And I know almost nothing about what that process looks like for software. I mean, obviously this is something that, is common in software development, but so sure. I think that's a great idea. And I know very little about what the actual process of doing that looks like. Beyond that, it seems like it should be possible, but would probably require sort of a targeted project. So I'd be really interested to try that.
Yeah, I think it might be that for some people English still is a bit of a barrier.
Yeah.
Some very good research is carried out in, for example, South America, Latin America, but where then the English barrier is causing data perhaps not to be uploaded.
Yeah, it's a really good point
to consider, and I've thought about it. For example, for Bacon to have error messages in different languages, it should be possible. Surely someone has thought about it. I haven't implemented it myself, but if you're thinking about more, say, widening accessibility, that might be something to consider as well.
I think that's a really good idea, and I can definitely certainly imagine some targeted funding that would. I mean, that's a nice scope of a project of trying to sort of improve documentation and things like error messages and even sort of function names and things like that in ways that would be more intuitive for non-native English speakers.
Great, thank you.
Thanks, Martin. I can imagine we've got this boat tool that spits out error messages in German that we don't understand, and there isn't help on the boat. I think Raul had something to say about this, about Martin's question, and then maybe Olumide, though I feel like I'm pronouncing your name wrong and I'm sorry.
Yeah, it's Olumide.
Olumide, thank you.
Thank you. Well, nice presentation, Nicholas. Actually, I tried following through. I would want to ask, because if you notice in most of paleo research discourse and studies, there's a huge gap between the North and the South, that is in terms of the research discourse. The global South is so disadvantaged, and there are so many factors that have been adduced. So what is Y2K, what is the 2K network doing about bridging the gap, okay, in terms of research participation and in terms of exploring the paleo potentials in the global South? I think my question is a bit fair.
Yeah, I think I will. Absolutely, it's a great question, and a very good point. And I think I will let some of the 2K network folks here talk about some of the activities that they have going on that are intended specifically to sort of increase participation and help people in the global South get access to both training data, research collaborations, those kinds of things that we'd like to see. I do think, I guess the one comment I'll make before I do that is that I do think that sort of the digitization and sort of the internetification, I guess, for lack of a better word, of a lot of this science does provide opportunities where a lot of the sort of data, it's good that for data to be globally accessible, and that doesn't matter necessarily where you are in the world. If you have an internet connection, you have access to these data. Now, I also recognize that there's beyond a lot of that, there's still a lot of advantages for those of us in the global north and in some countries in terms of training and funding and lots of other things that just to have everyone having equal access doesn't accomplish. But it's, as you know, a big topic, and I certainly don't have any silver bullets for a hard problem. But if someone from one of the 2K coordinators wants to comment on that beyond what I've said.
I can't see anybody jumping in, but I can say this: for speleothem data especially, a lot more data has become available from India, thanks to ISO2K and thanks to SciSal and efforts like that. So hopefully it is a move in the right direction. I think Kelly's question was next, and perhaps it's connected. Many of these tools have a high bar for entry to use. For those of us who train graduate students, what skills should we ensure our students learn to be able to be part of the next generation that takes advantage of these tools?
Yeah, thanks, Kelly. Yeah, absolutely. There's always a trade-off when we're sort of developing these tools and working with the data between sort of how flexible and powerful they can be versus ease of use. And certainly as the flexibility and power scales up, the barrier to entry also increases. And for the most part, we've aimed to keep those the flexibility and potential power of use really high, which has kept the barrier to entry really high. I do think that it is really at the sort of graduate student level that we want to be focusing this training, and that's certainly been a lot of our vision, is that we'd like to, as much as possible, we want to equip graduate students with these skills and then have them bring them back to their labs and train other people in their groups and their PIs potentially how to use them. I do think that sort of some level of sort of data stewardship training, data framework training, in addition to some code-based data analysis, is a really important part of sort of modern graduate training in paleoclimatology. I think that we can do better at increasing training opportunities. And actually, I think that's something that we're starting to do better. I'm excited about for example, the Paleo hack that was in February. I thought was great. Deborah and Julian did a really nice job organizing that, and we're really keen to expand those offerings and start doing them both more frequently and more often to help with this sort of and online, to make it the barrier to entry again a bit easier. So yeah, I guess that's what I'll say about that.
I agree. I'm attending Martin Trott's summer school as well right now on time series analysis, and it's online and free, and he does them frequently. So that's a good option as well. I guess Jack is next. Jack, do you just want to ask your question?
Yeah, so, well, great talk, of course. But so I guess most of us are paleo oriented. And since you're sort of developing lipid and all these other efforts, you might have the best perspective. I'm just wondering, like, where you think the paleo world is in terms of data stewardship compared to other fields, and maybe even those outside of the earth sciences, and whether or not, you're sort of drawing from that, or you think that, you have ideas that may be useful outside of our direct field.
Yeah, so I wouldn't consider myself sort of an expert across the breadth of science in data stewardship, but I do have, some perspective on this. I think that, well, different fields of science are in very different places in terms of the kinds of data that they work with. So I think that some of the fields that have made both some of the the biggest advances and receive some of the biggest benefits from, I guess what you might call it, like the data revolution, are those like DNA sequencing related work and like astronomy, remote sensing, some of these fields where the data are very voluminous. There's just ridiculous quantities of data, but also very standard in that, or they can be very standardized in that, it takes effort, but one can make all sort of DNA sequencers have very similar data outputs. And so then it's a matter of dealing with the scale of the data, less the sort of variety of the data. Paleoclimate is not like that for the most part. I mean, certainly we work with model output and some large data sets, but not to that scale. And really much more of the challenge in Paleoclimate is the diversity. Every site can be different. Every archive has a very specific sort of data and metadata needs and requirements. But we really want to integrate data across those different across archives, across disciplines. And so that has this, it's not so much a big data problem as lots and lots of piles of small data. So, or that's sort of, a catchphrase for this would be specifically long tail data sets. We're not the only community that has that sort of challenge. There's lots of other fields of science that are more sort of field-based. They're very disparate types of data. And some of them are certainly further behind than where we are. At least, I mean, we have a really strong culture that's been built up through the World Data Service and other organizations for data sharing, which is great, because I mean, you can't standardize or do much data stewardship if everyone's sort of hoarding the data. So that's really important, and not every field of science has that. And we're getting to a point where lots of data are available and are standardized, and reproducibility is a lot further along. So I guess my sense is that we're sort of in the middle. We're definitely not sort of a shining star amongst all of science for this, but we're also not sort of trailing behind.
Thanks, Jack and Nick. I guess this is the last question because we're running out of time, but I think I'll make it really specific, though the question is more general in the chat. With the global analysis, where there is missing regional data, do you think it really impacts the global analysis? So with missing data from, or how much does it impact, or is there a way to check?
I think I'm going to dodge that question a bit by saying that it really matters what the analysis is, like what the question is. I mean, I think for some of the like global or hemispheric scale temperature work that we've done, certainly there's data gaps that are really important to impact our understanding, but there's also places where data gaps are probably not very important for understanding global or hemispheric temperature because of the covariance in the climate system. So I do think that there are certainly systematic biases, like for example, for the 2K network, the fact that we know almost nothing about once you're beyond a couple hundred, times 100 years, what's happening in like the middles of oceans, which is of course most of the planet, is sort of a fundamental limitation that's really hard to get around because we don't have data for that, half of the planet. So I think, so in some cases it's fundamental and you can't answer questions because you're missing data in some places. In other cases, we'd love to have more data, but we still feel pretty good about being able to address the questions. So it depends on the question.
Sounds good. Thanks, Nick, and thanks, Harindra, for the question. I think you're getting thank you messages on the chat. I'll let you read that. Thanks everybody for attending. I'll just run through a couple of messages from Pages 2K. So today's session was by Nick, but it's a part of a seminar series, and you can catch all of the seminar series on the Pages YouTube channel. That's the link in the chat. The next seminar that we have is on the 5th of August. So that's next Thursday. And that will be a couple of hours before this time, wherever you are in the world. And it'll be by Jason and Nathan on annual reconstructions of global hydroclimate fields over the Common Era using data assimilation. And in case you miss any seminar, you can always find the recording on Pages. And this last one is a last reminder. We've sent emails about this before, but if you would like to be involved in drafting the proposal for Pages 2K Phase 4, or for participating in the coordination team, then you can write to Sarah by this Friday. That's the 30th of July.